Hi, I welcome everyone for the course Manipulated Robotics. It is a theory course. Today we are going to see an important topic in robotics, that is DH formulation or DH algorithm formulation or Denavit-Hottenberg. Okay, so why do we need this? Why we have to study? This is the standard procedure which helps you to find out the OM matrix. OM matrix. For example, this is your manipulator. So these are the joints. Okay, so here you have a end effector. Okay, so this is zero frame. This joint frame is one frame. This joint is two frame. This joint is third frame. This is fourth frame. So if I want to say what is the position and orientation of this frame, what is the position and orientation of this frame with respect to base frame, okay, or what is the position and orientation of the fourth frame with respect to third frame, or what is the position and orientation of the third frame with respect to second frame, or what is the position and the orientation of the second frame with respect to first frame, or with respect to zeroth frame. So these informations are clearly given by the standard procedure called DH formulation. Okay. So for that we need to derive the DH matrix. Before that we need to have a DH table. So how to get OM matrix? So OM matrix in this case is T40 is called as OM. This is the final OM. This OM matrix is fourth frame with respect to zero frame. So this says, because this is a transformation matrix, this transformation matrix is just 4 cross 4. Okay. So here this one is R1, R11, R12, R13, R21, R22, R23, then R31, R32, R33, and then here PX position vector PZ, then 0, 0, 0, 1. Okay. So this is the transformation matrix. So in this 3 cross 3 will say about the orientation, because this represents X, Y, Z of the current frame. This one represents X, Y, Z of the reference frame. So this is reference frame. This is current frame or moving frame. Okay. So this will say, for example, T40 means T40 means, so this is fourth frame. So fourth frame x-axis is compared with, or is referred with the reference frame x-axis. So fourth frame y-axis is compared with reference frame x-axis. Then z-axis fourth frame. Fourth frame of the means z-axis of the fourth frame is compared with x-axis of the zero frame. So likewise, this gives you the orientation of the current frame with respect to the reference frame. And then this gives the position vector. So what is the position in x direction with respect to reference frame? So this is the transformation matrix. So this matrix is clearly given by DH formulation. For that, first we should know the configuration of the robot, how it is configured, whether it is RPP, RPR, or RRR. So like this, various configuration. First, you have to make the configuration. Then you have to do the axis assignment. Okay, you have to assign the axis assigning. Then after that, we have to find out the DH parameters. Then DH matrix followed by OM matrix. So this is the flow. So this DH is having a systematic procedure to follow or to derive the DH parameters. Okay, so for that, first identify the configuration, then you have to do the axis assignment. Okay, let's take one simple joint. Okay, so this is the joint. Okay, so let's draw the axis. So let's say this is the z-axis rotation. So zi minus 1. So this is zi. Okay. So a common normal between this axis is common normal between this. Okay, so this is from this it is started, so it is xi minus 1. Okay, then for the other joint you have z axis, for this z and then z, between that you have a common normal, that is xi. So likewise it goes on. So now just imagine this is my ith frame. Okay, so this is my here is the I minus 1 frame. So here is the ith joint. Okay, so if you want to refer this ith frame with respect to I minus 1 frame, means we are going to join, we are going to merge this joint with this. Sorry. So we are going to join this point with this. So how am I going to join this? So let's take like this. So this is like this, zi minus 1 and zi. Okay, so you're having like this. So now I have to merge this point like this. So what I have to do is first I have to rotate this axis. So what I have to rotate? I have to rotate z minus 1 about what? About this xi minus 1. So you have to rotate zi minus 1 about xi minus 1. So how does it look like? Looks now. So it is zi. So this is also like this. Okay. So already you have this is my zi minus 1. This is my zi. So now you have rotated this. So you have subtended some angle. That angle is alpha I. So how did you get alpha I? Rotate zi minus 1 about the axis of xi minus 1 about an angle is angle alpha I. Okay. So now here we'll do this. Okay. So this one is rotated now. I mean like this. Okay. So this angle is alpha I. Okay. So which means this point, okay, here is the point. So here instead of here we can have we assume this point, this is the point, so we have rotated this, so it makes an angle alpha I, and then this is my xi minus 1. So now both are parallel. Okay, so now instead of reaching point, first I have to move in this way. So I have to move. So what is the next action? Next action is, first one is rotation, next one is, so let me say this is my one. Second point is I have to move. Okay, move along what axis? X minus 1 axis. What is the distance? AI minus 1. Okay, so this distance, so now it is moved. So now it is moved to this point. Okay, so it was here, now it is moved to this point. So this distance is AI minus 1. So here, now what happened is, so let's take your SZI. Okay, so now it is, I mean, it is moved means it is aligned like this. Okay, so let me take this. So it is aligned like this, so it is moved. So this is moved means this point is merged over here. Okay, so it is like this. Okay, or so it is my zi. So now it has moved to this point. Okay, so your this is my xi minus 1, and then this point it has xi is like this. Okay, xi, because this is a common normal between zi and then zi plus 1. So here is my xi. Okay, so now see this angle. So this angle is like this angle is like this. So in order to reach this, I have to make, I mean, I have to rotate this xi minus 1 so that this xi minus, after rotation, it will be, these will be parallel. So for that, what I have to do? I have to rotate by theta I. Okay. So what is the third point? Third point is rotate what? Rotate xi minus 1 about what axis? Zi around angle theta I. Okay. So now it is, so both are parallel. So now it is easy to reach. So what I have, mean, in order to reach this point, you have to just move. Okay. So fourth point is move. Move or move in what direction? Move in zi. So move along zi by a distance of This distance is called as di by a distance of di. Okay. So after di, it is reached. I mean, this point is reached. That's all. So in order to, I mean, here is the point. This point should reach over here, means merge with that, means we need four things. So we'll recall what are the four things. First point is rotate zi minus 1 by an angle alpha I about xi minus 1. Okay, let's draw that. Okay, so here zi is there. Okay, then here is your zi minus 1. Now you are rotating this. You are rotating this so that, so now you are rotating this so that it is parallel. Okay, it looks like parallel. So this is the one. Okay, so here I have to merge. So this is the point. So I have to rotate alpha I minus 1. So what is that you have to do? Rotate zi minus 1 by an angle alpha I minus 1 about what axis? Xi minus 1 axis. Okay, this is the xi. What is xi minus 1? It is a common normal between zi minus 1 and zi. Okay. Whereas xi is the common normal between zi and the zi plus 1. Likewise, it goes on. So now we have rotated. So this is my first one. So what is next? I need to merge. So it has to move in this way. Okay. So next point is translate. Translate along what? This is xi minus 1. So translate along xi minus 1 axis. Okay. So what we did? So this is my zi. Okay. So now you have merged with this. Okay, merged. So this is my xi minus 1. Now this is you have moved. So this distance is ai minus 1. Okay. So translate along xi minus 1 by what? ai minus. So you have to travel along this ai minus 1 translation. Okay. Now it is like this, and then here your xi is, so this is the point. Okay, so your the common normal is like this. Okay, so this is my common normal xi. Okay, so this is a common normal between zi and the zi plus 1. Okay, so you can see the angle difference. So you have this angle. So how did you manage this? So you have to rotate now. So what you have to rotate? Rotate xi minus 1 by an angle theta I about what axis? Zeta minus 1 axis. Okay. So now we have rotated. So this is theta I. Okay. So now after this, we have to move along this. So what is the next point? Translate. Translate along Zi axis by di. That's all. So these are the four operations. Okay. So we know that to get the transformation matrix, so I need to multiply this. So here I2 I minus 1. Okay. So for this, what is the first thing I did? Rotate along x-axis. What is an angle? Alpha. Okay. And then because we are proceeding further, so that's why it is post multiplication. Then we have done translation, and then we are moving along x-axis. So x-axis is A. Okay. Y-axis no movement. Z-axis no movement. Then we have done the rotation. Rotation along z-axis. Okay, so z comma theta. Okay, that is multiplied by translation along z-axis. So 0 0 d. Okay, so you multiply everything. So in this order only. But in some textbook they do translation and then rotation. But here, but whatever you do, you can. I mean, you'll get the same matrix, or the final arm matrix will be the same. Okay. So now, how did you multiply this for this? You know that for x-axis means 1 0 0 0 0, then cos alpha Sine alpha minus sine alpha cos alpha. Okay, this is the rotation matrix. Translation is, so this translation we need 4 cross 4, so better make it as 4 cross 4. 0, 0, 0, 1. Okay. And then in this, there is no rotation. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the moment is A. There is no Y. And okay. Okay. Then rotation along z axis. So 1, 0, 0, 1, 0, 0. So this one is cos theta minus sine theta, cos theta. Okay. And then there is no translation. So this one is 0, 0, 0, 1. Okay. So next one is no rotation. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And then here 0, 0, D. Here's the only translation. That's all. Okay. So this is the basic thing. So now we have to multiply everything. Okay. So I will give you the final matrix. So what is that matrix? So the form T T matrix, I mean transformation matrices. First C theta, then minus S theta, then 0 and A I, or just put A. Then while we do that, in this, we'll use that. Okay, or later we can do like this. I minus 1, so C theta I, S theta I, and 0 and AI minus 1. Okay, so next one is S theta I, C alpha minus 1, C theta I, C alpha I minus 1, minus S alpha minus 1, S alpha I minus 1, and then here minus S alpha minus 1 di. Okay, so here S theta I, sine alpha I minus 1, cos theta I, sine alpha I minus 1. So here cos alpha I minus 1, cos alpha I minus 1 di 0, 0, 1. Okay. So this is the matrix. So what you have to do is, first thing is, okay, for example, let me take one simple joint. Okay. This simple joint, a single joint. Okay. So this joint rotates like this. So here is my z axis. So this is my x axis. Okay. So for this, because in order to write the DH matrix, we need the in the first frame and the second frame. So in this only one frame we have. Okay. So we'll do some examples in the upcoming videos. Okay. So right now this is not necessary because for single joint we don't need DH matrix. So for this joint we need at least two frames to understand this. Okay. So this is my DH. So the concept is, I mean, first what we have done, first we have done rotation, then translation, then rotation and translation. Okay. So now what we have to derive the parameters. So what is alpha? So what is alpha I minus 1? So it is alpha I minus 1 is the angle between Z I minus 1 and Z I. Z I minus 1 Z I about what axis? X I minus 1 axis. Okay, remember this, x I minus 1 axis. Then what is ai minus 1? This is the distance between zi minus 1 and zi, and it is measured along xi minus 1 axis only. Okay, distance between zi minus zi minus 1 and zi along xi minus 1. Okay, so next one is theta I, because first we have done rotation, translation, then theta I. So theta I is angle between xi minus 1 and xi about zi. Then what is di? Distance between xi minus 1 and xi along z. Okay. So as a result, what we are saying is angle between z's is alpha, distance between z is a, angle between x's or theta, distance between x's or the di. Okay, so this is how these are the parameters, and so just summary. What is the summary? So first you have to get the configuration. Then you have to assign axis. Assign axis means Z and X. Okay, Y is not included. Third one is you have to frame the DH table. Then use DH matrix. Then fifth one is find OM matrix. So this is how we have to find the OM matrix or forward kinematics that matrix. Okay. Thanks for watching.